Well, Neil, we're here to talk about the poetry of science. I would say that science is the poetry of reality. And one of the things that I feel a bit humble in your presence, biology being a kind of junior science to physics, I suppose we both have something to learn from each other, but I can't help feeling I've got rather more to learn from you than you've got to learn from me. Maybe we're both a bit naive about each other's subject, but I think I'm a bit more naive about yours because there's more to be naive about. I forget who it was, he coined the phrase physics envy.
Yes.
And I think this shows itself in lots of fields, perhaps less so in biology than others. So what we're going to try to do is to have a conversation between a biologist, an evolutionary biologist, and an astrophysicist, a kind of mutual tutorial without a chairman to get in the way. And I thought we might begin by noting that what we can see with our sense organs is an extremely narrow band of what there is to see, and this is particularly so with the visual sense, and we can see a tiny narrow band of the electromagnetic spectrum, the rainbow. But the rainbow's width is tiny compared to the vast expanse of the electromagnetic spectrum. And I see that as a kind of symbol for how limited our understanding of the universe is as well, because after all, we are evolved beings who evolved to understand the interactions between medium-sized objects moving at medium speeds. And this ill-equipped our brains to understand the very small, quantum theory, and the very large, which I suppose is covered by relativity. So I find myself as a mere biologist baffled by some of the things that physicists talk about. And just to throw out one example, in the expanding universe, we are told, and I have to believe it, that everywhere is, as it were, the same as everywhere else. There's no one place which is the edge of the universe. How can that be?
Well, Richard, first of all, you said you're told it, so you have to believe it. I will never require you to believe anything.
Good for you. Well done.
It will only ever be about how compelling is the evidence to you. But you started with our sensory organs and landed in the expanding universe. Can I take us back to the organs and then perhaps land in the universe?
Yes.
The urge to think of our senses as being powerful or good is strong because first, that's all we have. Second, we like having nice thoughts about ourselves rather than miserable, depressing thoughts. So we're prone to walk around celebrating, for example, the power of sight or of taste or of smell. When, of course, when you really want to smell something, you bring a dog and their nose smells much better than your nose smells. I was going to say the dog smells better than you, but that would insult you. So their nose smells. So we already know that our senses are feeble, and we reach to other creatures in the animal kingdom, cite them as having better examples of our sight, of our taste, of our smell. But little did people know much before a century and a half ago that our sense of vision is limited only, as Richard said, to the colors of the rainbow. And it's quite extraordinary to realize that, for example, beyond red, there's something called infrared. And beyond infrared, there are microwaves. And beyond microwaves, there are radio waves. Go the other direction, you go beyond violet, ultraviolet. Beyond that, X-rays, gamma rays. Energy goes up as you approach gamma rays, with dramatic consequences if you have gamma ray exposure, by the way. Of course, we all know you turn big, green, and ugly, as the Hulk had experienced. But the point is, the visible light part of that spectrum is a tiny slice, and the universe doesn't only communicate with us through that slice, as we had taken for granted for so long. Most of the history of the telescope, which is itself an extension of our eyes, extended the power of our eyes, but not the range of our eyes. And it wasn't until we first understood maybe we're missing something in the 19th century. The 20th century came decade by decade, new telescopes in each newly discovered band of light. And only then did we learn about black holes in the universe or remarkable, violent forces operating in the centers of galaxies discovered by radio telescopes. So, yeah, we're practically blind out there. And it's humbling, by the way, but that's the whole point of the methods and tools of science, to not only extend your senses in the domain in which you understand, but to take them to places they've never been before. On top of that, we have methods and tools that detect things that are not even extensions of your senses. You have no clue what the magnetic field is around your body right now. You have no clue whether or not you're being bathed in ionizing radiation right now. You'll eventually figure that out as limbs start falling off, but while it's happening, you actually don't know. And there are other things that are more subtle, like polarization of light. So when I think of the scientist's toolkit, especially the astrophysicist's toolkit, it's all about how many different senses can you bring to bear, technological senses can you bring to bear on decoding the universe. One of the things we've discovered, now getting to your horizon question, we look around the universe and it looks like we're in the center. What an ego-supporting concept that is. You can either go around continuing to think that, feeling good about yourself, or study the problem and learn that in an expanding universe where the speed of light is finite at 186,000 miles per second, forgive me using miles per second.
I prefer miles.
You do? You got that on tape. You're an Oxford professor.
No, it's true. Nobody talks about kilometers in Britain.
Oh, good. All right. So we share not only most of our language, we share miles still. And inchworms, what do they call them? They're not centimeter worms, right? They're inchworms.
We don't have that sort of stuff in Britain. That's Europe.
Of course, Britain is not Europe, as we're constantly reminded. That's why here we have the English breakfast and the continental breakfast.
Yes,
They're very different breakfasts that you can order here. So this horizon problem is actually quite simple. And rather than explain the full-up nature of it, let me just give a simple example that is entirely analogous. When you're a ship at sea and you look out, your horizon in every direction is the same distance from you. Depends on your height above the sea level. That's why ship decks are high. They see farther beyond the curvature of the earth than you do just standing on the main deck. So your horizon is a perfect circle centered on you. You can conclude that is the extent of the entire earth, or you can imagine, suppose I'm in another spot. Well, that horizon is still true for whoever happens to be in the middle of it, but now you've moved to a new place, and you will see a horizon corresponding with that spot. And so everybody has a horizon at sea, yet no one at any time is thinking that that's the full extent of the ocean or the full extent of the earth. We have a horizon in the universe, so does the Andromeda galaxy. The galaxies with names that look like phone numbers. We've got, if you travel to those galaxies, they will see the edge of the universe now in 3 dimensions, in every direction, at the same distance from them, just as we see for ourselves.
That does it for me, provided that the horizon is that which we are capable of seeing. I could follow that if you said that for any part of the universe, the horizon is the bit before the expanding universe has disappeared over the horizon.
Yes.
Which means it's no longer visible.
Yes.
No longer, but it's still there, even though we can't detect it.
It's true with the ocean when you're at sea.
Yeah, but is anybody on my side here?
You want it to be a harder problem than it is. I'm just simply saying, so here you go. Here you go. The radius to our horizon is about 14 billion light years.
Got it, okay.
Okay?
Yeah.
If we sat here or returned to this spot 1 billion years from now, that horizon will be 15 billion light years away.
Yep.
It's actually an expanding horizon because the light from 15 billion years light years away will have had time to reach us. Right now, it's still en route.
Yeah, I have no problem with that, but beyond the 14 billion year...
The problem is the universe wasn't born yet.
Yeah, okay.
That's the problem.
I know.
Okay? So you can't see the universe before it existed.
So why doesn't somebody...
Invent a kind of telescope that
No,
can?
no. Okay, I'm getting out of my depth here. Let's get back to...
No, just to clarify.
Okay.
Just to clarify. So it takes light time to reach us, and the universe hasn't been here forever. When you combine those two facts, you get an edge of the universe. And so the universe has been here for 14 billion years. The farthest thing that could send us any information is 14 billion light years away.
I get that, but what about the guys who are on the edge of what we can see? How can they see beyond the other side?
Oh, because here's an interesting point. We don't know whether or not the entire universe is infinite.
Okay.
And our horizon is, the universe could be twice our horizon or infinitely larger than our horizon. Same with the ocean. You don't know how much bigger the ocean is than your horizon is. You can keep sort of wandering around. Maybe you'll hit land, as we've done, of course. So now you go there. If the universe is really, really big, that will be the center of their own horizon. And whatever the age of the universe is for them at that time, that will be the radius to their horizon.
Yeah, okay. I just want to make a remark. You drew the analogy of the sense of smell, or what a poor sense of smell we have. It's a fascinating fact that although dogs, for example, have a much better sense of smell than we have, as you mentioned.
That's what I say, sense of smell. That's what I should say. Not
Well,
that dogs
okay.
smell better,
Yeah.
but they have a better sense of smell.
Yes.
Thank you for that.
But we have the genes that would once enabled our ancestors to have as good a sense of smell as dogs. But the genes have mostly been turned off. And so we have vestiges, we have historical relics of those genes. And it's like your hard disk on your computer that's cluttered up with remains of old chapters you've written here and there and things that have now been cut off. Those genes have been turned off, but they're still there.
Isn't that the premise of X-Men?
I don't know.
They're human, but they have a genetically different genes are turned on and off within them, giving them special powers. So are you suggesting the day might arise where we go inside the human genome and flick the dip switches on and off and we come out as
Put
Superman?
it this way, it's not as unlikely as it might have appeared before we realized that we do have those genes still. You don't have to import the genes from dogs, although the technology of this coming century may enable that to happen.
I'd still rather it be the dog that sniffs the bomb than me.
Yes. Well, we'll probably have robots to do this sniffing. So what about this point about the difficulty of maybe I chose a too easy an example. The brain, how is it that the human brain, which evolved to do really rather mundane things.
To not get eaten by lions, yeah.
To not get eaten by lions in the Pleistocene of Africa, because as you'll learn this evening, we are all Africans. We all come from Africa, and our brains were shaped by natural selection on the African plains to do things that involve objects like this. I mean, medium-sized objects. Macroscopic objects that don't move anywhere near the speed of light. It's a tremendous tribute to our species that we are capable, at least some of us are capable, of understanding things that don't belong on that ordinary macroscopic, slow-moving scale.
Yeah, and so therein is the value to us, not only of the methods and tools of science, but also of the language of the universe that we call mathematics. Remarkable thing, a point first advanced by Eugene Wigner, that math has an unreasonable utility in the universe since we just invented it out of our heads. You don't discover math under a rock, as you might find a grub's. You invent it out of whole cloth. Yet, it empowers us to provide accurate and predictive descriptions and understandings of the universe. And so what comes of this is you learn to abandon your senses. And it's a line from the Broadway musical, Phantom of the Opera, abandon your... never mind. Sorry. So I want to write Broadway lyrics one day in another life. You train yourself to abandon your senses because you recognize how they can fool you into thinking one thing is true that is not. You abandon them, you use your tools that do the measuring to say, okay, that's the reality. Then you make a mathematical model of that you can manipulate logically, because math is all about the logical extension of one point to another, and then you can make new discoveries about the world that, frankly, you'll just have to get used to. No longer do you have the right is not the right word, but no longer do you have no longer are you justified saying that idea in science is not true because it doesn't make sense.
Absolutely, yeah.
So nobody cares about your senses.
Yes.
Your senses came out, forget the Serengeti, just growing up. As a kid, something's in your hand, you let go of it, it falls. You tip a glass, water spills. You are assembling a rule book for how nature works in the macroscopic world. The microscope takes you smaller than that, the telescope takes you bigger, and other laws of physics manifest themselves in those regimes that you have no life experience reckoning. And so it's math that allows you to take these incremental steps beyond the capacity of your senses and perhaps even the capacity of your mind. Yes, it's the mind that's taking the steps, but your mind was not deducing that by just looking at the world with your senses. It was helped out. It was aided by these tools that we invented.
And at some point, when you get so used to doing the mathematics, it becomes kind of intuitive in rather the way that I'm told that pilots who get used to flying a plane, and they start to feel the wings of the plane as being almost part of their own bodies. They develop an intuitive feeling.
No, so how many, is this common, is this a common sensory perception of pilots?
Yeah, I think it is. It's a common thing. I think that when people get skilled at using micromanipulators, where they're using their hands, and what's actually going on is tiny little minuscule movements going on under a microscope.
So it becomes their hands.
It becomes their hands.
The plane becomes the pilot.
Exactly.
Or the pilot becomes.
And just as you said, the telescope is an extension of the eyes.
I knew this. My advisor in graduate school, one of my advisors, I spoke to him one morning. He was doing research on star clusters that have these huge orbits around the center of the galaxy. He said he had a dream the night before where he was one of these clusters, and he was orbiting the center of the galaxy. I thought that was so cool.
Yes.
If you start becoming in your cosmic dream, I want to have those dreams, because then you think creatively about what remains to be discovered.
Absolutely. I sometimes wonder about whether surgeons, maybe even surgeons of the present, who are using micromanipulators inside a body. I mean, something like when they stick that thing up you and it goes.
They stick a lot of things up you.
Okay.
The last I've heard.
And I mean, already you have surgeons driving an endoscope inside and turning left to get round the intestine, turning right. I imagine the time will come when a surgeon will have virtual reality goggles on, and the surgeon will actually feel herself to be inside the body of the patient, and will turn left and will literally walk across the room, and that will be translated into the micromanipulators, the endoscope moving.
This sounds really cool. I like this idea, and you know what you'd have to do? You would have to alter the dominant laws of physics in that regime, because if you're small enough, a la Fantastic Voyage, the 1960s film, when you're that small, capillary action and surface tension and all manners of other forces take over.
Yes.
And that then becomes your new reality, your new sensory
That's right.
standards.
You would have to become sensitive to surface tension. Darcy Thompson made the point in, I think, 1919, that to world of an insect, gravity is negligible.
Completely, it's who cares.
What matters is surface tension.
That's right.
And you'd have to be that. I never thought of that. But what I do
That's because you didn't see the movie Bug's Life.
Okay.
In Bug's Life, They serve up a cocktail to an insect that goes up to a bar, and all the bartender does is pour out water from a spigot and hand him the bowl of water, like that. And the surface, this was brilliant of the cartoonists here, of the illustrators. And then he sticks a straw into the sphere and sucks it out. No receptacle needed. You got to get out more.
Well,